begin right where everything begins, atomic radius. So you need to understand some properties of some group 2 elements here. So you have group 2 elements which are in group 2 electrons in the outer shell, as you can see here, 2s2, 3s2, 4s2. So 2 electrons in the outer shell, therefore they lose 2 electrons to form ions of a charge plus 2. And you need to know that, as you can see here, doing some SPDF notations here, you see that the number of shells is increasing going down the group. Therefore, atomic radius is also increasing as you go down the group. You're adding more shells, extra electrons, extra shells. Therefore, your atoms are going to be bigger. So you have a trend here going up in terms of ionic radius. Let's go to ionization energies. So since the atoms are getting bigger, more shells, more shielding, that means that you're going to have less ionization energy as you go down the group. So in terms of ionization energy, it decreases going down the group. This is because extra shells are added as you go down the group, and hence the outer electrons are further from the nucleus, which weakens the attractive force of the nucleus on the outer shell electrons. Therefore, they become easier to remove. So you need to build a vocabulary there to explain this trend. Yes, something to note is that we are also increasing the number of protons going down the group. So the nuclear charge is actually increasing. However, there are these 2 counter effects which offset this increasing positive charge. Though it's increasing, but something is reducing the effect of this charge, which is the shielding effect. The shielding effect here, due to the the many electrons. Okay, and also we are saying here the atomic radius is increasing. So we have two effects really that are working against the increase in nuclear charge, which is atomic radius is increasing and also shielding effect is increasing. This is important to take note. Reactions with water. Yeah. All right, let's go. Serious business here. So what happens when these react with water? Group 2 elements react with water to form bases. So just remember this. According to this equation here, you form the hydroxide and hydrogen gas. However, there is one element which behaves differently, magnesium, which reacts slowly with cold water but more vigorously with steam. So for magnesium, you need steam to have an increased rate of reaction there. So it forms magnesium oxide instead of magnesium hydroxide. So this one forms an oxide instead of the hydroxide. And also take note that when these elements react with the water, the reactivity increases as we go down the group. So this is due to what we said. It's easier for these electrons to lose electrons. For these elements to lose electrons as we go down the group. There is a larger atomic radius, and also there is a high shielding effect, like we saw. So this makes the elements more reactive going down the group. This is interesting. Group 2 elements with oxygen. So this was with water. Then with oxygen, what happens? They form the oxides. But you also need to take note here that the hydroxides are bases in nature, and so are the oxides. They are also bases. So you have your magnesium plus oxygen here to give magnesium oxide as an example. And just remember that they also happen to be white solids at room temperature, the oxides. They can react with halogens, for example chlorine, to form the salts, magnesium chloride in this case. And take note, the charge is always +2 because it's in group 2. We're talking about group 2 here. Now the oxides, what happens when you react the oxides with water? So you made your oxide, which we said is basic in nature. Now what happens when you react it with water? You form the hydroxide. So this hydroxide is also basic, and most of the hydroxides here are soluble, except for magnesium oxides reacts very slowly, and the hydroxide barely dissolves. So this one is less soluble, but most of them are soluble. So they would give you the ion and the hydroxide ions, the oxides when they react with water to form the hydroxides. The hydroxide then dissolves to form for you these two. But for magnesium oxide, it's very slow, and for beryllium oxide, it doesn't react with water, and all the hydroxides that may be formed are insoluble. So they become more strongly alkaline as you go down the group, as the hydroxides become more soluble. So the more soluble they are, the more alkaline the solution that are formed. So just remember this about the trends concerning the reaction of the oxides with water. So since we say the oxides, the hydroxides are basic, they can neutralize. So they can react with acids to form a salt and water. That's neutralization. That's an example, calcium oxide plus hydrochloric acid to give you your salt and water. And if it's a hydroxide, it would form for you the salt and water as well. It's neutralization. Then let's talk about solubility. Let's talk about solubility. What happens with these elements, where compounds? So for group 2, you need to know there's a trend here. If a group 2 metal is joined with an anion, a large anion that is a charge of 2 minus, then there's a trend when it comes to solubility. If the anion to which it's bonded has a charge of 2 minus, then the solubility is going to decrease going down the group. If the anion to which your group 2 metal is bonded to has a charge of 2 minus, then the solubility decreases going down the group. But if the anion has a charge of -1, then the solubility is going to increase going down the group. So remember this to try and help you memorize the trends and the trends in solubility there. Okay, this is another important aspect, decomposition. So I'll end with this one and I'll continue in the next video. What happens when you have carbonates of group 2 metals and nitrates? So they decompose upon heating and they form for you the for the carbonates you get the metal oxide and carbon dioxide gas, and for the nitrates you get your metal oxide, nitrogen dioxide gas, which is brown, and oxygen. So we'll look at what causes differences in thermal stability for these elements. So enjoy your study. I'll meet you in the next video. Please subscribe, like, and share this video if you found it very helpful. Thank you.